Okay guys, welcome back to part 2 of characteristics of quadratic equations. So we're working on page 7 right now, example number 2. And we're going to graph this function or sketch a graph of this function using a table of values. To remind our table of values, we're allowed to choose our inputs. So those are x values, and it'll give us an output or a y value according to our equation. So we can pick any value of x we want, but in this case, I've given you a table of the ones we're going to try. So looking at this first example, we're going to sketch the graph of y is equal to x squared plus 4x plus 3. So our first input is going to be x is negative 3. So what we're doing is I'm just going to write it on the side so you can see what I'd be calculating. So I'd be doing negative 3 all squared plus 4 times negative 3 plus 3, and I would number crunch that in my calculator, and that would give me the output value of 0. Okay, moving down to the next one, I'll do the same thing again, but using negative 2 as my input. So I'd have y is equal to negative 2 all squared plus 4 times negative 2 plus 3, and that gives me an output of negative 1. Make sure you guys are putting brackets around those negatives when you're putting it in your calculator. It will affect your output. Next one is y is equal to negative 1 all squared plus 4 times negative 1 plus 3. And that will give me an output of 0. Y is equal to 0 squared plus 4 times 0 plus 3 will give me an output of 3. Y is equal to 1 all squared plus 4 times 1 plus 3, and that will give me output 8. So make sure you guys are trying these and make sure you can get them in your calculator. Last two, we've got y is equal to 2 all squared plus 4 times 2 plus 3 gives me 15. And then the last one, 3 all squared plus 4 times 3 plus 3 gives me an output of 24. Okay, so in order to actually graph this, I'm going to use those values to make a coordinate point and then plot that point. So our first coordinate point is going to be the point negative 3, 0. So on my graph, I am going over to x is negative 3 and then staying right on the x-axis because y is 0, plotting that point. The next one we've got is negative 2, negative 1. So I'm going over to negative 2 and then down to negative 1, plotting a point. Next, we've got negative 1, 0, go over to negative 1, and then we're staying right on the x-axis. Zero, 3, so x stays the same at 0, and then we're going to go up to where x is 3 and plot that point. 1, 8. So going to the right over to 1, and then we have to go up until 8. And then last two, we've got 2, 15. Would be, we're moving quite far up now, 15. Yep. And then last one, 3, 24. So that one's going to be way over at the top at 24. Okay, so you can kind of see it's got that like curved looking shape. So that's our parabola shape. So I'm going to try and I'm going to attempt to connect the dots. Hopefully yours will look a lot nicer than mine. You should see kind of a smooth curve going up like that. And there should be arrows on either side because this graph could keep going in both directions if we kept calculating more values. Okay, so let's look now at some of the characteristics of this graph. So the first one we're going to look at is the x-intercept. So that's where we see it crossing the x-axis. So we've got 2 in this case. So we've got 1 happening at -3, 0. And the next one is at -1 and 0. So notice that the y coordinates are both 0 in that case. Okay, our y-intercept is where it's crossing the y-axis. So there's only one of those. And in this case, it's at 0, +3. So my graph isn't drawn perfectly, but you see where that point I plotted is. The axis of symmetry, remember from the last lesson, is the point where you can draw that imaginary line and you could fold your graph in half and it would be symmetrical on both sides. And that line always goes right through the vertex. So in this case, that's going to be our line of symmetry there. And the equation of the line of symmetry comes from the x-coordinate of that point. So for us, the x-coordinate is at -2. So our equation is just simply x is equal to -2. Okay, the coordinates of the vertex, so that's that lowest point where the axis of symmetry goes right through. So the vertex is going to be at -2 and -1. Domain is always all the real numbers. We see every value of x exists on our graph if we were to extend it in both directions. And the only time we won't have XER, remember, is with applications. So range is the trickier one. We have y such that, and since we see that there's a minimum point, all of our graph exists above that point. So all of the values of y must be greater than that minimum point. And in our case, the minimum point is at -1. So that's that question done. Looking at the next question here, example 3. So we're going to now attempt to draw a sketch of a graph when we're given a little bit of different information. So we've got the quadratic equation here, x squared minus 2x minus 8. And they told us that we have x-intercepts at -2 and 4. So those are the 2 points where it's going to cross our x-axis. So I can plot those points already. So it's going to be at x is -2 there, and then at +4. Okay, so we need a little bit more information though to sketch the rest of it. So if we look up here to question A, it says, is the parabola opening up or down? So reminder from the last video, we can tell if a parabola is going to open up or down by looking at the leading coefficient. And in this case, the leading coefficient is the number 1. So it's the value before the x squared. We don't typically write the 1, we don't really need it, but it's still there. So it is a positive number or a positive leading coefficient. And we saw from our last video that when we have a positive leading coefficient, a positive is smiling, so it is going to open upwards. Okay, so we're expecting our graph to do something like that. And if we're opening upwards, we can kind of see that dip down in the middle. That means we are going to have a minimum value. Okay, so you're walking down the hill, you'll hit a minimum before you go back up. Question B says, what is the equation of the axis of symmetry? Okay, so this is kind of a new concept to us here. So we know what the axis of symmetry means. It's that line directly down the middle of our graph where we could fold it in half. The only real information we have so far are those two x-intercepts. So we actually know that the line has to go right through the middle of those 2 points. They're going to be symmetrical. So what we can do is actually find the average of those 2 points. So what we're going to do is actually add them together. So I'm going to do a 4 plus -2, and it doesn't matter which order you add them together. And then we find averages by dividing how many terms we have. So in this case, we have 2, so I'm going to divide that number by 2. So 4 plus -2 is +2, and 2 divided by 2 is 1. So there will be an axis of symmetry when x is equal to 1. So I'm going to go to my graph and I'm going to draw that axis on. So it's going to go right through the middle. Oh, that's not the middle. Like that. Next question says, what is the y-coordinate of the vertex? Okay, so again, another kind of new concept here. All we have is an axis of symmetry, an equation, but we don't know where that y-coordinate is going to be. But we do know the x-coordinate. We know it's going to happen when x is 1 because it happens right on that symmetry line. So we know that we get the y-coordinate when x is equal to 1. And that piece of information is coming from the fact that we found that line, the axis of symmetry in question B. So I'm going to sub in x equals 1 into my equation in order to get the y value. So it's going to be y is equal to, what's the equation? X squared, so 1 squared minus 2 times 1 minus 8. And that is giving me -9. Okay. So our vertex is at +1, -9. So now I've got that point. So let's go back and plot that on my graph here. +1 and -9, and it should be right on that line of symmetry that I've already drawn. From here now, it's going to be tricky for me, but we can just connect the dots. So let's see if I can do it. So from that little vertex, I can draw a line up, and line looks kind of pointy, and kind of extend it past there. Okay. So we've got kind of a rough sketch of what that parabola would look like. Okay, if I go back down to question D now, state the domain and range of the function. So domain's the easy one. X such that x is an element of the real numbers. It's all the values if we extend the graph in both directions forever. The y-coordinate, or the range, is the little trickier one. So we say that it's y such that, and we see we have a minimum value, so y is going to be everything bigger than that value. So y has to be greater than or equal to that minimum point of -9. Okay, a couple more questions and then that's it for today. So the next page you'll see here some instructions on how to use your graphing calculator. So definitely feel free to read through those, but I'm going to just do it with you in this next example and kind of explain how to do it on the calculator. Okay, so example 4, given the quadratic equation, we've got y is equal to x squared minus 5x plus 4. We're going to use a graphing calculator to determine the following things. So you need your graphing calculator again. The first one says the window settings used. So I'm going to move this over for a second. So we're going back into our calc. Hit your y equals, and let's type the equation in to start. So x squared minus 5x plus 4. And then we did this before as zoom. So I'm going to hit zoom and then standard, number 6. We will change it in the next question, so I'll show you how to do that soon. But now it's asking us for the window settings used. So we're going to go back up, and there's a button that says window here. So if you click on that, this is the information the question's asking us for. So it says the x minimum. So what's the smallest value of x on the screen? The x maximum, the biggest. And then this weird looking one, the SCL, that stands for scale. So if we're looking at all the little ticks on our graph, it's going up by 1s each time. Same with the y values, we've got it going from -10 to +10, and each one of the little ticks represents a 1. So here's how we write it. So on our page here, the notation that we use looks like this. So I'm going to do x with a little colon, so I'm talking about the x values. Maybe I should let's write the format down first. So the format always goes minimum value, maximum value, and then the scale. Okay, so doing the x ones first, I'm going to do x so that I know I'm talking about the x values. Our minimum on our calculator goes from -10 to +10, and then our scale is going up by 1. Ditto for the y, it's going from -10, +10, with a scale of 1. Okay. Now, question B is asking us to figure out the vertex. So I'm going to go back to my graph. I can see the vertex. I can see it's this little minimum point here. So I'm going to get my calculator to actually tell me what the value is. So you're going to hit second, and then trace. And then you can probably guess it. It says a minimum, because I'm looking for a minimum value. And you hit number 3. Now it's asking me to do a left boundary. So I know this is the point I want right at the bottom here. So basically our calc is saying pick a value on the left-hand side. So my cursor is already on the left-hand side. So I'm going to hit enter. And now it says the right boundary. So I have to move my cursor over until I'm sure that I've passed that minimum value. So I know it's on the right-hand side now. And I'm going to hit enter. Now your calc is going to ask you to guess. It's not super important for us, so you can actually just hit enter again, and it'll jump and it'll find that value for us. Okay. Now my calc is, sometimes they do this. It's got a lot of repeating 9s there, so we're going to round it to 2.5 is what it really means. So the vertex here is at positive 2.5. And then it's down at -2.25. So that's the coordinates of the vertex. You can see x and y. Okay. The axis of symmetry happens right on the vertex. So I know the vertex is at 2.5. So the axis of symmetry is going right through it when x is equal to 2.5. Domain and range, x is always a real number. And in this case for y, we had a minimum value, so it's going to be everything that's bigger than or equal to that minimum value, -2.25. Almost there, guys. This is our last question. So if we scroll down, we're going to do a quick word problem, quick application here. And it is pretty challenging, so I'll try to go slow. So we've got a ski jump that was recorded in a frame-by-frame analysis. You can kind of see what it looks like as he jumped. And you'll notice he jumped off of a small kind of like jump here, and then he lands at a lower place down below. So they determined, the magical overlords determined the equation of this jump was y equals negative 4.9x squared plus 5x plus 1. So let's use our graphic calculator to draw it, and then we'll be able to sketch a basic picture here as well. I'm going to move my face over. So go back into your y equals, clear, and we're typing in, make sure you use the negative button, 4.9x squared plus 15x plus 1. And now what we're going to notice if we click graph, not our best window settings. It cuts off the maximum point. It's really, really skinny. It's not our best. So here's the question where we're going to have to change our window settings to make it fit everything a little bit better. And it is a little bit of playing around and sometimes guessing and checking. So I'm going to click the window button, and looking at the values of x, if we go back to the question, it told us that x represented time. And then it told us that the y values measured the height above the ground. So I've got my x-axis representing time, and then y represents the height above the ground. So what that means for x is I can't have negative values for time. So I'm going to set it to, I personally like to do -1 instead of 0, because then it's not squished at the bottom of the screen. And our x max, it might have been okay. I think I actually set it in a little bit smaller, and I think I kind of matched what I had in my notes here, so I put it as 5 instead. And the scale going up by 1s was fine, so it's going to go 1, 2, 3, 4, 5. For our y values, same, we're not going to have a negative height above the ground. So instead of 0, I like to put -1, just so it's not squished at the bottom of my screen. But we do need to extend the height of our graph. So the one that we have in our notes goes up to 20, so that's not a bad one to choose. So let's choose a height of 20, and the scale of 1 looks like it's going up by 2s on our picture there. So I'm going to change the scale to 2. So once we're happy with that window setting, we can click graph, and that looks way better and way more representative of our application here. Okay, so let's do some of these questions, and then I can sketch my graph as well. So it says, graph the function in our calculator and sketch the graph, and then state the window settings that we used. So our window settings, we chose to do x went from -1 to 5, and we had a scale of 1. And our y went from -1 to 20 with a scale of 1. And keep in mind, guys, that these aren't the only possible answers. You could have done 0 to 10. You could have done something a little bit different, as long as you see all the important information in your screen. If I am going to sketch this graph now, you got to look really, really closely, but our graph actually starts at 1. Great. Here, if it'll drop for me, there we go. So it starts at 1, and then you have to look really close. It looks like it maxes out kind of past 12, and then it comes back down just past 3. So this is just kind of a rough sketch. We'll figure out all the details here in a second. Something like that. It's a rough one, but hopefully yours looks a little bit better. Okay, So now it says, determine the skier's maximum height to the nearest tenth of a meter. Okay, so we're going back to our calculator to get it to help us. So you are going to hit the second trace, and it's asking for a max height. So maximum now is number 4. So now it says left boundary. So you're going to move your cursor all the way over to when you're sure you're past your max point on the left and hit enter. Then move it back till you've passed it on the right. Hit enter, and then you can hit enter one more time and it'll jump to that maximum point. Okay, so it's not a perfect number because this is an application, but that's okay. It says to the nearest tenth of a meter. So we see a max. Oops, I'm going to rewrite that. So there is a maximum at, our calc says 1.5 and 12.5 when we round to the nearest tenth. Okay, so that's our maximum point. Now it says determine the skier's maximum height. So from that information, we have to pick out what is the maximum height. And we said that max height is our y values. That's the distance above the ground. So he hits a maximum height of 12.5, and we want to use units, which for this question, our units are meters. 12.5 meters. Okay, for question number C, letter C, when does he reach this max height? Well, we already figured this one out. It happens when he's at the max height, which is our vertex. So from the previous question, it happens, the max height happens after 1.5, and I think it was seconds. Yeah. Okay. And that came from our previous question there, our vertex that we found. Question D says, state the range of this function in the context of the situation. Okay, so now we're talking about context. So you have to be very careful. So our range is going from the lowest y value to the maximum y value. And we have to be careful, it's a word problem, so he can't have a negative height. That just doesn't make sense, right? So the lowest height that we see on our graph, so if you look back at the calculator, so he takes off of the jump, he's a little bit above the ground, but he does land back on the ground at the end. So the lowest height he can be above the ground is 0. So y is greater than or equal to 0, but it's less than or equal to the max height, which we already figured out to be 12.5. Okay. Question E, what is the y-intercept of the function, and what does it represent in this situation? So there's a few ways that we can figure out the y-intercept, but I'll show you how on the calculator, and then we'll talk about what it means. So hit the button second, trace, and then the option number 1 says value. So you can pick number 1. And now you see that it's blinking x equals blank. You can tell your calculator what you want it to be. So we know that the y-intercepts happen when x is equal to 0. So you can type that into your calculator, 0, hit enter, and it'll jump and tell you where that y-intercept is. So y-intercept happens at 0 1. So y when time is 0, so x is 0, why is he already a meter off the ground? Well, we can see it in the picture. That's where that jump is, right? So he's taking off of a small ramp, and the ramp must be 1 meter high. So we have the skier takes off of a jump 1 meter high. Okay, so that would be the context. Okay, last question. So on the next day of training, the skier increased his speed before the jump. The equation that models the skier's new jump is given to us. How much higher does he make it? Okay, so we're going to go back into our calculator question, and we're going to type this new equation in. So go to your y equals, and we'll clear. And now we're typing negative 4.9x squared plus 17x plus 1, and we're going to click graph. Okay, so it's still an okay window setting. I can still see all the information. We're going to find that new maximum height. So second trace, and then maximum is at number 4. So we're going to go to the left side of the max point, hit enter, go to the right side, enter, hit enter one more time, and it'll jump to that new maximum point. Okay, so the new vertex is at 1.7 and 15.7. So to be careful, read the question really carefully. It says, how much higher did he go? So we actually want to figure out and compare the difference between the old height and the new height. So we've got, move this over. So the old height that we had was 12.5, and now our new height is 15.7. So we're going to subtract 15.7 minus 12.5 is 3.2. So the skier jumps 3.2 meters higher the next day. Okay. So that's it for the first lesson here of characteristics of quadratics. So you've got a summary that you can read through there as well, and a bunch of practice questions. And then make sure you reach out to myself or Mr. Saw with any questions that you might have. We are happy to help you all. Talk to you soon.